So to confirm, yes, it's telling me that I'm recording now, and I'll turn off my camera. It's not needed. Let me share my screen. I'm going to use another Zoom functionality tonight or today, because I find that Zoom functionality that comes with Windows maps control sequences in a different place than I usually do. So I use a lot of control keys to communicate with the Radar and WebStorm application, and then it's very unfortunate that these control sequences are captured by the Zoom functionality. So I'm using Zoom-it. It's another Microsoft product, but yeah, it might be to see something strange on my screen sometimes, and that's because this Zoom functionality is quite new to me. So today's topics is, as declared, data models for tables. But you would see when I save this change later today, I added another section to this list of topics is being scheduled, and that is a dedicated section for data models related to logic. I had initially thought to include logic in the data model review today, but I realized that I should try to keep it as uncomplicated as possible, even though these are complicated structures. The complication is that these three elements are actually not separate as such. These are all linked together in lesser degree for some, but in high degree for others. And I would say the complexity of the solution comes from this link between a data model, the field model, and also the logic model. The links are necessary to facilitate certain functionality, which you would not get from a pure data model unless it was also linked to the field model. But I will show you and highlight where these functions overlap and what benefit we get from this linking. So let me give you guys some background to my work on data table models. So what I'd like to start with is kind of some observations I made when I started working in Aldrega many years ago. So to give you some background, I'm a guy who don't like to repeat myself too much. So if I do a task 10 times, and it's a repetitive task, I've done it before and know what to do, I know also that if I've done it 10 times, I would more likely have to do it 10 more times. And that gets me to thinking into how could I optimize it so that it can do this task quicker. And in a nutshell, this is what I'm trying to achieve with these new data models. By the way, I'm using a term unified to signal the latest revision of these ideas. So I have a unified data model, I have a unified field model, and logic model. And the goal of these models is just to reduce the overall complexity of the current solution, because Aldrega has existed so many years now. And the way we're approaching it so far is if we have some new functionality requirement, or even if we're fixing a bug, we often introduced new coding, like code lines. And if you add a code line, you inevitably increase the complexity of the solution. So, and if you continue this trend over many years, then you get into the situation where it's very difficult to maintain and make further progress in the application. And I think I talked about this when I talked about clean coding principles. So I actually brought up an example to how I experienced this, and we used to have, and I think we have more now, 350 distinct activity entity properties. And even for an experienced Aldrega developer, if we were told or needed to add a single new field into the model, it took us all the way to up to 4 hours to do that. Sometimes if you had not done it for some time, you would forget and you would have to spend more time trying to research how to do it, because we didn't actually write down this as a guide until very lately. Anyway, this process doesn't scale. So if you needed to add 10 fields into the data model, then you would have to multiply that time you spend by 10 times. And of course, already there you can see there's a good situation where you want to optimize it. We did actually, myself and Anatoly at that time, we did actually add support for dynamic field on a project level. The idea was that the user should be able to define his own fields, regardless of what was already predetermined by the system. So, because a common idea would be that we wanted to use these fields in portfolio setting. And in a portfolio setting, you might want to have a number of new categories, text numbers, pick lists on a project level. And we implemented this quite some time ago. And we did it in such a way that these were kind of an addition to the existing classes. So the problem with this approach is that even though this is, I would say, a minor complexity added to the existing ones, it didn't actually touch upon the existing classes at all. So already the 350 fields that we already added were not affected by this. So another fact was that if you look at the 350 fields, these are already been established in certain classifications like number, text, etc. There's not that many classifications that we make on the field, but if you study the classifications on the fields, that you will end up, if you group them by classifications, you will only have like a dozen or so distinct groups. So the 350 fields could be actually thought about as 15 fields or 12 fields, depending on the number of classifications variants there are. Anyway, that's kind of the background to my data model. There's also some obvious clues in the model, in that all the models or the base functionality that I have is suited for modeling the database structures. I think any model that we choose to work with should reflect much of the functionality that we have from our database solution. So I hope you will see this, that the data model fully encapsulates all the functionality you have in a rational database. I won't go into too much details on more advanced functions for SQL query generation. That's kind of out of scope until you know more about the field model. But just know that it's possible using the logic and the field model that they established to run very advanced queries into the database. And I would say also very optimal queries. I would say that it can match or even improve on what you see generated by framework entity and other solutions. But we'll come back to that, and that's something also Elena, I need also to help me out to improve even further improvements on. But okay, but let's start with the basics then. My data model is layered, and there's 3 distinct layers on it. And the first layer is as simple as you can get, and that is, the first layer is thought about as a dictionary or current dictionary. In fact, in C#, you would see that this layer is actually a concurrent dictionary. In Angular, it would be just an object. All Angular or JavaScript objects are, in a sense, dictionaries. And by the way, these 3 layers, I managed to map them quite successfully to Angular or JavaScript, or TypeScript, I would say. It needs to be an object-oriented language. But you would see that all of these 3 layers have their same equivalent in our TypeScript code. And if I have time, I will show you the TypeScript equivalents. So after the first layer, we have what I'm referring to as the entity row layer. And this is a layer that sits between the contract. This is fully linked against a specific field model and the dictionary. Basically, this has some usability functions on it, and also some minor requirements on how the data should be, what attributes should be associated with the data. So let's just go to some code and show you guys. So now this is, you would see in the unit test framework, it's already checked into the develop branch, so you can take a look later. What I'm trying to do as a new policy is that I have a subdirectory called the contract. So for all the main dynamic contracts that I've been working on recently, I created a dedicated test class on it. And you can see there's very little setup code for this now. It used to be lots of more work to set up a class to be a framework for unit test, but now I managed to make it very simple. So I do encourage you to even create your own unit test classes when you work on new functionality, or if you want to create unit tests around existing classes or functions. Anyhow, we were talking about data layers. And this is the first data layer, which is basically just a dictionary. I said that we're actually using concurrent dictionaries in the background, and that is true. I will show you this. Hopefully you can able to read the syntax. This is a very convenient way in C# to create a dictionary. It has a string as the key, and it has an object as the value, so it could be of any type. And my data model is based on this dictionary. So my data model doesn't make any assumption as such of the data itself. It could be any type. But it needs to be coded against a key value. So that's the first lowest level. Now let's go a bit deeper into the dynamic, the row level. So on the row level, you can actually create an entity of the row by casting it to the dictionary from dictionary. Basically, I created some convenience functions. So you can see here, I accept here in the constructor a dictionary object, and it will create a entity dynamic row instance included in the concurrent dictionary, which is created from the input dictionary. So this is like a data transformation from dictionary to a concurrent dictionary, which is then closed in the dynamic row. So quite convenient syntax. So this single line actually does quite a bit of work. Now, these 4 lines, these 3 lines, I would say, are there to tell you a little bit about some primary attributes that a dynamic row instance has. So the row itself has a CRUD. It's a common abbreviation for create read, update, delete. I'm sure many of you already know about this term. So this allows the data row to declare if it's to be passed into the database as an update, if the row is supposed to be deleted in a database, or if the data row is to be introduced into the database as a new entry. So included in this row is data that you can actually use when communicating with SQL to make these kind of actions happen. So that's why it's there. This is actually the link we have from this data layer to the field model. You already heard me say that I have a convention where I talk about SQL class, SQL table names and SQL column names. My way to identify what a field is in the data model is the same way. I'm actually borrowing the same string identifiers. So this identifier is unique, and it will allow me to get data from database from the AD task table and the AD task column in this table. There's also something I recently introduced, which I had to do to simplify the solution, is that also on this level, there's a status to say what type of row this is. So in this, it could be, for instance, that this row is associated with the activity entity. So these three primary attributes that you kind of add to the already existing dictionary data. So this is the first layer. This is the second layer. You can think about this as a wrapper around the first layer. It adds some usability functions, and it adds certain attributes to the dictionary. Now, this is the major step, and that is from the row layer to the contract layer. And there's much happening in the background when you move from these two layers and into the last one. And I will go into the functionality, but hopefully I've been able to achieve a very simple API when you use these layers, and hopefully you will be able to make use of them quite easily. If you struggle in understanding what to do or how to use them, then please let me know, and I will try to make it even better. There's always possibility of improvement, right? So just know that I'll be very happy to get some feedback on how it's actually working, and if you've experienced any problems, then please communicate with me, and I will try to find a fix for it. Anyway, I wanted to introduce you to the contract layer. So what I recently did was to I wanted to access a data table in the database. We already have an existing solution to reading data out of this database table based on entity framework. But I'm actually moving away from using entity framework altogether because we now have similar or even better implementation, I would say, in our own data model. So I wanted to show you how I managed to create a data contract with all the inherent functionality that this new data model gives us, based on the recent improvement I made by creating this class. So let's examine the database, and let's go to user settings. It's actually stored in a table called home user settings, and you would see that it has 18 columns here. These names are not following the convention we usually use in C#. In fact, they are kind of outside of the regular convention altogether. We usually use capital names for the columns. So but that's kind of beside the point. So let me just show you how I glued this data table into the contract. And the first step of doing that is to establish an interface. So I did that by creating this interface class, or sorry, it's a class, it's an interface. So what I did is to take all of these columns, add it into the interface. I made sure that the types are mapped correctly. This is kind of a manual process, and it's very quick to do if you make use of the advanced editing functionality that we have in Raider. So, for instance, if I wanted to make a change sorry. Now it's the zoom functionality is preventing what I wanted to do. There we go. So say I wanted to make a change and make these float, for instance, then you can see that I have to do it only once for these lines, because I'm using the way to select multiple rows. And the way is you press on the Alt key and you highlight the rows that you want, and you can move the cursors like this. And I can select names. I can, for instance, convert it to camel case, like this. So you can see, very, very easy to do now that we have these advanced editing functionalities. So even though the code is not auto-generated, it's very easy to map the tables to an interface like this. So having established the interface, I will then generate the class. So I create this class that incorporates the functionality for the interface. And you would see that this again follows a very regular pattern, in that it's based on a base class and it implements the setter and getters this way. So just know that all these properties are not plain properties. They all are associated with a getter setter, and this is kind of the magic, where this magic happens with all the advanced functionality that is inherent to the data model. So again, from the data table, I create the interface class. From the interface class, I create a class derived from the dynamic contract base, which implements all the different properties in such a way that you see here. So we're hopefully quite easily understood. So once I have done this, I can do certain actions which wouldn't be possible otherwise. Let's see if I talk about everything. So you can see that I created the class. Now, if you create the class instance, then instance should have its own entity setting. You will see that in the constructor here, it has a default setting. This is important as a fact for later. The paths, which are basically a column description for the table, should not be empty, because I passed it input that should not be empty. So the input should contain paths, basically. And you can see here, let's just go one step back. This was the dictionary that you saw. It contains user input, a text input, and a Boolean input. This is passed to the constructor here. And you can see here, this name is now something you can use. So again, the dictionary used the original table column name, but the generated contract is using a different name for the same property. And this is very important because I wanted to be able to create a flexible data model that retain all the existing property names currently used by the current business logic. So it would be very much work to introduce a data model which changed the names of all these properties. So it was very, very important for me that when I introduced this flexible data model, I could exactly reproduce the same property names as the old models had use of. So hopefully you can see this, that I have this plan page enabled, which is actually associated with this database entry. And it's accessible in a typical way in C#. So this could already have been used in some logic. Currently it's a new class, so it's not in use for now, but it could have been an activity contract, and this would then easily be fitted into the existing logic for handling activity data. So again, that's the contract layer, how it's constructed based on a dictionary via a row, and then lastly this. So yeah, this is the first layer, this is the second layer, and this is the third layer. There is some functionality that you can do on the second layer, and so I want to show you this. So this is something Anatoly worked with recently. He added a caching solution on the server side, and as part of the solution that Anatoly created was the ability to merge partial records into an existing data set. So you should know that the new data model is such that you can read parts of these data sets into the data model, and then you can add more data from the database at a later stage. And this action of merging is actually now encased within the functionality which we have for the entity dynamic row. So basically, the second layer now contains the merge logic that is needed to merge these records. So I am doing this sample here. So in the previous example, you can see you have these three attributes set. But when I introduce this attribute, I can actually merge it into the complete set, and then I can then query the sets, complete sets property, and we will see it's true. So this is actually proof that the merge operation is successful. Anyway, so basically now we should have a good understanding that the data model contains three distinct layers. And you also saw how I created a contract layer based on mapping a SQL data table to the contracts. Now, one of the things I wanted to solve in a convenient and easy way was some complexity that we have inherent to the existing data models. For instance, if you think about a simple way of thinking about percent values, you often would think about percent values in one of two ways. One is a value between 0 and 1. And that's the most common way, I think, to think about percent values, because they are often used in mathematical expressions where you are multiplying this percent value into some value. And then, of course, you would want to have it in this scale. But visually, you would often see the scale of 0 to 100. I think this maybe is a good way to display it for a user to get a better understanding of this, the percent value. But you would be surprised actually that in a database, we store percent values differently depending on what field we are talking about. So some fields would be storing their percent values in this range, but other percent values will be stored in this way. Now the old code, it didn't have a problem with this because everything was dedicated to the field as a singular implementation. So it had its own instructions to read and write. It has even its own instructions on how to put it into the as visual representation in the UI. So basically, everything was segregated and dedicated for a single field. But now that I wanted to establish a model to include all of these percent values, I also wanted to find a way to simplify it. And you would see that even though we support still an internal difference in scale, so you can accept 100 value from the database or 1 value from the database, as it flows through the data model and finally to the visual representation, the formatting is such that the formatting is done on a range of 0 to 1. So the output of the data model, when it's passed to be displayed, make sure that these percent values are always in the 0 to 1 range. It means that the display code is simplified in that you can always expect the range to be in this sense. There is an additional complexity, and that is that in the database we have different opinion to how big the precision should be when storing data values. Sometimes we use the SQL float, sometimes we use the SQL real, and sometimes we use SQL int. Again, this wasn't much of a problem before because we actually handled all the calculations dedicated to a single field. But I found actually some places where it had been working, but there were problems actually in that you had been treating a double value as a float value and vice versa. So I wanted to make sure that when we store the underlying data in the dictionary, it's stored exactly in the representation that is in closest to the database. But it so happens that even though the float value is stored in the dictionary, sometimes you want to use it as a double value in calculations. And I also made sure that the data model knows to convert between the different value types. So let me just illustrate what I talk about here in percent conversion and also in type conversion. Just a second, guys. I have a phone call. So, and this simple test just illustrates what I'm talking about. So I'm declaring here an activity, and I have a setter functionality, as you saw. All properties on a contract is passed with a setter, and all properties are retrieved by a getter. Now, the setter functionality has many attributes. One is that you can actually give any input to it. It has an object input. You can see, well, not an object, it's actually a typed. So in this case, then it would be a string input. I'm referring the field it should be passed to. And if I run this unit test, you will see it's actually going to succeed. Yeah, let me do this way. So even though I'm passing a string, of the value 1 into the property, I can actually request to be retrieved as, and it will actually be returning a double value 1.0. But you will see that if I actually ask the dictionary itself, recall that the data is actually stored in a dictionary, and the dictionary is actually one-to-one with the database format. You would see that in this case, what we would be storing into the database is a value of 100. So these 3 lines illustrate just what I talked about, in that the data model is set up to handle type mapping and data conversion. So that's included and already functioning out of the box. So you don't actually need to know too much about how to use it. All the complexity in handling mapping to be correct for the database is already part of the API and handled for you. Now, a data model isn't, I think, complete without actually having some guidance to how to serialize it. And we had one employee, Sergey, who created the first framework for our Angular client. He was the one who introduced into Drega the concept of transposing columns and rows. This wasn't actually a practice I was too familiar with before he introduced it, but on an example I will run soon, you will see that if you transpose columns and rows in a JSON file or a JSON dataset, you will get a much more compact serialization result. I applied some additional optimization techniques of my own. I often find that there's a lot of string properties that are duplicated in these serializations. For instance, if you have activity text value, then often the activity text value will be repeated on many activities. So in that way, it will be beneficial to just save, as part of the serialization, a single instance of this string, and then have the string just being mentioned as a reference for all these properties that are using the string. So that's part of the serialization process. There's also the fact that many of the fields that we have available for activity level are not in use, or it could be given a default value. So if you have an understanding on both the receiving end and the transmitting end, what is a default value, you don't actually need to submit it on the data channel. You just filter it out before you send it into the pipe, and you reconstruct it as you receive it from the pipe. So let's just go to the code and show you how serialization is taken care of. Again, I'm using this sample of a data contract. In this case, it's the user settings data contract. I have a loop that creates 20 such contracts. I have a unique identifier for the user. But you will see that I have only 2 different string values for the last planned page. And I have only 2 different, or I have 2 distinct Boolean values for if it's enabled or not. So again, the contract is based on what you saw previously added from the database. Now, I added serialization class to do all of the heavy lifting regarding creating the JSON. So you can see here, I create an instance of the serialization class, passing it in the contract. I retrieve the JSON string in this way. Then, just to confirm that everything is working okay, I deserialize the JSON string in this way. I ask for the first instance of the first contractor created up here. It's now been serialized and deserialized, and then I check that they are equivalent. So I can run this as well. And it's successful. Now, one thing I wanted to highlight, which is a technique I've applied on a regular basis now in my unit tests, is the line down here, which is quite interesting. Say I want to make a change here. Say I want to have projects 2. Then I'm making a change in the unit test manually now, but say that this was introduced by something else. And I wanted to validate that the JSON serialization string isn't affected by these changes. So if I run it now, you would see that it's failing, and I will try to explain why. Just get it to fail first. But obviously you can see that I changed the input of the serialization. Now you would see here a window opening, and it's actually a window showing us the expected results on the right side here. You can see it's called verified. And it's actually, this is the new result generated by the unit test. And you can see down here that the new version of the unit test is producing activities 2, whereas it used to be producing activities only. So this is a very interesting technique, and it saves a lot of testing code, because the unit test is associated with a file that contains the original result. And so say that I wanted to make sure that this is actually valid, I can run it again. And if I say that, okay, that's actually what it should be, I can actually just copy everything from the left side to the right side. I can save this as a new updated reference file, and I can close it. If I now run it, you would see that the unit test is succeeding. So basically what I have is that I'm passing a string to this constructor, and that is a constructor in a NuGet package called the verify, and it maintains these text files alongside the source code you see here. So if I go to the commit now and look at the changes, you would see that there's actually a file here. If I look to the difference, you can see the same here. So basically, if I wanted to save this to GitHub, then when you run the same test, you would actually succeed on passing a test, because now the verified file contains exactly what you wanted to have. So this is a very convenient way to make sure that if you have lots of textual things to validate, you don't actually need to put the validation code in the unit test itself. You can actually rely on it being saved in a separate text file like this. So it's very, very easy to use. So this is this single line I needed to trigger all of this activity or all this functionality. So it's very convenient. But actually, the file here itself is quite interesting, because it highlights some of the functionality that I applied for serialization. You would see that I have, as you know, 20 contracts created and it's passed to serialization, and this is the JSON serialization output. And you can see here that the user ID is listed as an array. The last plan page is an array. You can see that the number of these elements are half of what you saw above here. here's the 20 values. But this is because false is default for Boolean, right? So you don't actually need to pass it as part of the serialization. And you can see also that the text fields are there are only 2 mentionings of these. And it's actually up here where these text fields are mapped to distinct rows. So hopefully you get now a sense that the implementation we have for serialization is quite efficient. It could be further improved on, but again, that would add more complexity to it. So I think it's something we can defer to later, because already now we have quite a large shrinking in size you otherwise would see when you just use plain JSON serialization. Yes, so let me go back to the overview. So we talked about type handling and data conversion as part of the data model. We talked about serialization. Basically, this is what you exchange between the web client and the server, both ways. I have implemented the same serialization logic on the Angular side. Now, the last thing I wanted to mention and show some examples of is the SQL query generation, which also is an integrated part of the data model. This would not work without actually having a link to the field model. And also, of course, when you save into database user input in the activity level, you will also be needing support of the business layer to do some calculations before you put data into the database. Otherwise, the data in the database wouldn't be valid, actually. So that's also why I would say that the SQL generator is also linked with the data, the logic model. Anyway, I created this set of unit tests for you to show you how you would be reading a data contract from the database, how you would be deleting a data contract, and how you could create a data contract. So let's just go through how you can read a data contract from the database. So first off, you need to identify in the database what columns you want data from. Now, it used to be that you needed to do this with some code which is very formal and long-winded. I ended up with this solution, which I think I hope you are happy with. So what you do is that you create a template contract, and you actually assign it values into the fields you want to read out of the database. So it doesn't have to be any existing users. It could be any input here. Also recall that these properties are basically type safe, right? So it doesn't actually matter. But what matters is that they are referenced. Having referenced it this way allows the data model to know that you in fact want to read from the database a value from the user UID column, from the last planned column, and enable column. So having referenced this in the template, and when you read the data from the database, only these 3 records will be read. Sometimes there are you will see that it's reading more data than what you have referenced here, and this is the case for where you have actually forgotten to mention key values. The data model knows what a key value is. So for these are 2 key values. There's user UID and client UID. So even though I haven't referenced client UID, you would see that the SQL code that is generated actually makes sure that the client UID is also passed from the database to the code side here. So that's kind of the preparation that you make. Also, you want to inform the SQL query generator of some properties that you want to be using. So in this case, I'm using a flag called dry run with validation. It means two things. One, the data will not be passed into the database. So if this would be like a save instruction, because the view also defines the scope of a save of action, as well as a delete and read, then you know that the data is not saved to the database, but the data query that is generated is actually passed to the SQL Server for validation. So basically, the SQL Server will examine the generated SQL query and inform you if it's passing syntax check or not. So now that I define some properties on the request, I can actually get a reply from the database, and this is the way I do it. And you can see now this returns two properties. One is the data read from the database, but in fact, I set it with dry running, so it will be an empty table. But what is interesting here is that it's actually returning this generated SQL query, right? So this allows the unit test function to capture the generated query and put it into a file. So if I go back to the Explorer, and if I examine this and go down to the list of files here, I should find that we have the test files for contracts. And this is the one I wanted to open. Sorry, this is the wrong one. This one. You can see here, when running the unit test, the generated SQL query will be passed into this file. And you can see here, when reading data in the way we just saw, I have a template. I says it should be validated and the query should be returned. I get the query back and I put it into the file. Then the file will contain this input. You can see here that, as I said, the number of columns is limited. It's limited to the 3 down mentioned here, but there's a fourth, which is a client UID, which is something I didn't mention, but the data model knows, based on its link to the field model, that it should be included. Now you would see that in this statement here, it is a blank, it doesn't have any filter on it. So how would I declare a filter for the query? And it's very simple, actually. So you can see here, this is the way I generate the query for all entries. This is the similar expression, but you will see that I'm adding a filter statement. It's a bit verbose, but hopefully you will be understanding what it does. Basically, you tell the query generator to apply a filter on the query. The filter should be against the user UID with a value of -1. And you can see here, when you run it, it actually does what you wanted to do. It actually selects all of the same fields, but now it will limit it to only be selecting where user UID equal -1. So basically, everything is the same apart from this section here. So this is a way to affect how the SQL query generator can give you the where statement. I should quickly mention that this filter functionality allows you to use all of these different operators. So equal, not equal, contains, not contains, less than. You can see what I see here. And these are implemented by the like functionality in SQL. Anyhow, so that's reading. So go back to the. So we want to also show you how to delete an entry. In this case, you create an entry which has the key you want deleted in the table. Now, as you remember, the row has a status called CRUD state. In this case, you would mark it to be deleted. And then you create a delete request. Basically, it's a view with a request used to set data changes in the database. And so the view is passed, the data is part of the serialization, and you want to mention also the update paths. So this is a bit more complicated than reading, and it necessarily is more complicated. So I don't want to go into much details because I will go quite extensively about the SQL query generator, and I'm already pressed for time. But you can use this sample if you wanted to already before I have a chance to talk about the SQL generator, to use this sample to know how to delete records in this table. So just follow this pattern and it should be easy to do. If you wanted to introduce new elements to the table, so in this case, I wanted to introduce a new record called user UID. Then I create such an entry, and then I flag it to be created. Yes, this is just a check I did to make sure that the field mapping is properly handled. So ignore this for now. Then you create a request to be passed for this set paged action. And when you do that, you will get request to create. So if I go back to the output, you will see the data to be deleted and also the data to be inserted. One thing you might be surprised about, Elena, if you look at this closely, is that even though the test itself, when you're creating the entry, only lists 1, 2, 3 properties, the generated query contains many more properties, and these are because these values are non-nullable in the database. So there is actually some checks in the solution to make sure that you create the non-nullable values if they're not specified by the user, and in this case they will be given default values. So I think that's sufficient for detail level on SQL query. So sorry, wasn't my intent. Go back to the overview. So I talk now about I talked about data layers, type handling, serialization, SQL generation, and I want to spend 10 minutes of your time extra now to talk about Angular support. But I can't talk about Angular support without actually going into some details on how we use a code generator called NSWAG. I forgot to add a mention of this. So NSWAG is a huge system, and it's used by many of the larger companies. It's basically formal declaration of what should be exchanged as far as data between different APIs. And then it will generate a C# code, PHP code, many different, you can see here, even C#. So, and it's been in place many years, and it's heavily used. And what I did, I borrowed a small part of this functionality as a NuGet package to help generate the contracts, because when Sergey started setting up the Angular web client, he manually created everything on the Angular side, basically by manual labor. So if we had a contract in C# code that we wanted to use as a means to carry data between the server side and the Angular side, then it was created initially in the C# code, because this was loading data from the database, and you implemented often the server side first. But then to have it received on the Angular side, you would have to have created a recipient, right? So he manually created these classes. Now this is not necessary anymore. So you would see that, for instance, this activity data contract, which is exactly a copy of what you would see in the C# code. This file is not created by anyone manually, it's generated. So I wanted just to show you how it's generated. So basically, as part of building a build pipe, I have this script. You can see it's under Jenkins. The script is called run nswag. It's a bash script, you can see here. So everyone should be able to run that from their command line. And it also does, it examines two files. And the files are corresponding to DLLs in our C# code. So if I go to the core nswag, you will see the class names mentioned for all the classes I wanted to pass to the code generator. And you would see the activity dynamic contract is mentioned here. At the bottom, you would see that the reference to the DLL, which is is processed by the code generator. And at the bottom, you would see the output destination. So this is the destination in our Angular framework where these classes are stored. So let me just run this quickly, because there is one more important fact you should know about. If I run this manually now, I would get source code generated in the Angular framework, which would not compile. It will break Angular compilation. And I'll just show you why. So if I go to activity dynamic contract now, you would see that it's looking differently. If I go to the bottom of it, it's a very large class. You will see that it has created additional functionality to it. And this is functionality which is default in nswag code generator. But having tried to introduce this framework with Sege, who's originally created these classes manually for hand, he objected to this move because he thought there were too much boilerplate code here. He said we don't need this. We only need this upper part. So what I did to accommodate him was that I created program, which is, you see here. So having run the nswag, it's very important to have some to also remember to run this patch nswag output. And by the way, Elena doesn't need to think about this when she builds the installer. This is part of the build pipe. But if you, as a developer, wanted to make changes in the generated source files in Angular, you need to make sure that you run both of these commands, one after the other. So you would see if I run this now, it manipulates the file so that it actually removes all the unwanted boiler code. So if I was to go down to the bottom here, you will see that it actually terminates. No boilerplate code anymore. But it also does a few more things. I do a scan of all the Angular code, and I tried to report on duplicated elements because I wanted to make sure that we should move away from the manually maintained code and rely on the generated code. I think it would be a very bad idea in the long run to have two different versions of the same classes. One maybe out of date manually created one, and one generated by the new code generator. So this is kind of a warning list for myself that I should find some time to go back and make sure that I removed the previously manually maintained files. So yeah, that's something I hope to have time to do just after we have finished this current release phase. I should mention that it not only generating classes, it's also generating a large number of enums. So if I scroll, I guess to somewhere I can find it. So you can see here, the current state enum, which is part of the data contract, is actually also part of this code generated file. So I don't need on the Angular side to declare this formally. It's actually part of the file that is generated. So now the last thing I wanted to mention in Angular, you know, if you take it back to where I started, then let me collapse this. I can do like this. I talked about these 3 data layers, right? The dictionary. There's no formal declaration of the dictionary as such in C# or in Angular. Just know that in TypeScript Angular, you will be using an object, basically. The entity row is part of the generated code. Here you can see it. So it's part of the code that's generated. And if you look to the activity dynamic contract, this is also generated. But in C#, you could actually make use of the activity dynamic contract, which you would see that in the test files that I've been showing you guys. These are contracts that you can directly use. It was unfortunately not as easy to set up in TypeScript, but I did find a way to do it. So if I look to the implementation of this generated file, you will find that it's actually applied here, and you will see the same kind of pattern with setter getters being created for all of these different properties. So basically, if you study the Angular code solution and the TypeScript and the C# solution, you will find that it has the same layering. So layer 1, layer 2, layer 3, and this is in TypeScript. This will be layer 3 then. So yes, I think that's it for now. Hopefully you get a general sense of the data model and what it achieves for us. My recommendation would be to try to convert to this data model if you are accessing data that contains more than like a handful of elements. I think some tables are very simple and doesn't need all this fancy support. But in many cases, you would see that you get so much extra benefits of using this data model in most of your work that I think as you get accustomed to using this API, you will find yourself converting it to it and using it more and more. Hopefully that is the case, and hopefully I haven't made it too difficult for you to step into and start using this. So again, just to repeat myself, this was a breakdown of the data model for tables. You don't have the full picture yet, because I also need to talk about how the data model interacts with the field model, and also how the data model interacts with the logic model. And of course, I haven't said anything specifically in detail about unit testing or the most interesting topic, I think, would be for many of us is the actual SQL generation implementation and what it has, what capabilities it has. So already past 1 hour. Are there any questions or comments?
Sorry, Front. Small comments from my side. About our time for adding some fields, I think that 14 hours it is extra time, of course, because it is time include support new fields in all models. But okay, it is not important for now. Could you clarify for me if we want to add new fields in Adrega, should we add data in AD fields table for new model or not? Or we should add new columns in table only?
It's a good question. So what you're asking is that, say I wanted to introduce a new property to the home user settings, right?
Mm-hmm.
Sergey recently did this by adding some portfolio properties to it. Where would you go to introduce these properties to be formally declared? Then if you wanted to allow user to browse this in a table, but you wouldn't be using it as part of business logic, then there's only one file you need to add it to, and that would be this file. So basically, after having introduced this new column in the database, if you wanted the user to be able to select it in a column selector to be introduced into a table, then you need to have one row in this file. That's everything you need to do. So basically, add it to SQL, and then you add a single line in this file, which I haven't mentioned yet because it's part of the field model, but that takes care of everything for you. Now, it's a bit more complicated if you wanted to make use of that field in your business logic. If you wanted to support the field in your business logic, then you need to also formally declare it in the interface. So you can see here, all of these properties are being mentioned to be referencing an interface. That it's not needed actually, but it's needed if you wanted to make use of this field in a unit test and have it directly accessible. So even though it's not formally like this, it can be accessed in unit test, but then the access is a bit more difficult. So for convenience sake, I have this link between the SQL entry and the interface. So this is the file that sets up this link. Did that answer your question, Elena?
In general, yes. And if, for example, I want to add new fields in system view, as you know, in some models we have system views. It means that I should update JSON string because you keep structure of view in JSON.
To answer that question, or the answer to that question needs to be delayed, Elena. We haven't created the view model yet.
Okay.
So and when we create a view model, we will handle a number of different scenarios. And one is, of course, is what should be the default table layout. For instance, if there's a new user who hasn't created his own custom layout on a table, what should be the default view for the user? And should the default view be owned by the administrator, or should it be owned by Adrega as a company? Should it be kind of hard-coded in the release, or should it be customizable by the admin? All of these questions we need to put into the view solution, but we haven't done that formally yet. So we have a way to go there, but hopefully we will find answers to all of these questions and have a solution within a few months.
Oh, okay, understand. It is questions for future. Okay, thank you, Brent.
Anyone else have anything to ask or comment on? No. One thing that I wanted to mention, and to be honest, I was a bit afraid for performance, given that we're storing every data now in a concurrent dictionary. How does that affect performance? I think I already validated that partially by having implemented the Angular, the VPF Gantt report engine, using an earlier version of this data model, and it didn't seem to be affecting the performance. I think, hopefully you will correct me if I'm wrong, but I think what we saw as performance from Gantt print in the desktop client was comparable to what we see as performance in WinForms. And of course, WinForms is the traditional static model, and Gantt print is the new one. I think now in the next version we have Gantt, which is the unified Gantt model that we are now using in our Angular Gantt editor. It's even much quicker than we had seen before. So my concern about general performance, I think I could put to the side, because I think I've already now proven for myself and hopefully the rest of the team that the performance issues are on the positive side. We can only be expecting better performance having converted to the data model that I'm talking about here. Okay, that's everything for today then. And just know that I will be submitting a minor update to my talk now. Let me in fact do that immediately. I'll commit and push. Yes. So I hope that everyone has some time then on Monday when I wanted to talk about the next chapter. And this is not less important. It's actually very important, and that is how I managed to create a field model which allows you the same flexibility for creating JSON queries as you would write when you write manual queries or hard-coded queries. So yeah, I'll talk more about that on Monday. And yeah, it's Friday, so then I wish everyone a good weekend, and yeah, see you on Monday. Bye-bye for now.
Bye-bye.
Have a nice
Have a nice
weekend.
weekend.
Have a
Bye-bye.
nice weekend.
For
Bye-bye.
time.
Bye-bye.